Okay, so hi everyone. Yes, I'm giving this talk from Madrid. Nice weather, sunny. Um, Probably better weather than in Glasgow, even though I'd really like to have been able to be there. And my talk is going to follow up nicely on Claudia's talk and results as well. So I'm basically going to talk about bias in recommendation. This has become a hot topic in the last few years. And I would say that most perspectives in work so far has focused like on removing the bias or um, somehow coping with it or avoiding this bias. So what I'm going to talk about is more about like taking a step back and actually asking the question, like, do we really want to remove the bias? Is the bias, in principle, we are biased against bias, I would say, but I think we all know, I mean, since we're at this workshop, that bias is not a simple issue. It's not necessarily a bad thing. It's useful. It helps us uh, even survive, I would say. And so this is going to be the starting point of my talk. I will share with you some thoughts, some experiences, some findings, some ideas. So the main questions that I will address is like, should we, I'm going to talk in particular about the majority bias in recommendation. This has arisen already in Claudia's talk and also in Rishab's talk. And the question I'm going to make is like, should we recommend popular stuff? Should we avoid that every time? Or what are the trade-offs in recommending or avoiding majority choices in recommendations? So this is the outline of what I'm going to be talking about. I will start with some general ideas and making connections, kind of some, I would say, thinking out loud in a way. And from that, I will focus on recommendation and the bias in recommendation and how it shows up and you know, like the questions that come to mind when we see those biases. Then I will go a bit deeper in analyzing what is this bias, the good and bad possible effect, and how to better understand it. And of course, I will end with some conclusions. So we know that fairness, bias, coping with bias is not simple. There is no like universal, simple formula to deal with bias and fairness. We know that fairness is not just about being uniform. Like, for instance, you don't want to allocate resources uniformly across people, but you may want to take into account the distribution of needs. Likewise, if you are hiring people, you can have like multiple angles on fairness and multiple definitions. Like maybe you want to hire the same number of people of different groups, gender groups, ethnicity, or you may want to hire a proportional number of people from each group, or you may want to ensure equal opportunity that, you know, for equal qualifications, all groups, people from all groups have the same probability to be hired. Let me show you another example. This is actually a query that I tested on my smartphone. So I went to Google and I entered the query, is the Earth flat? And so Google didn't even wait for me to press enter. So right away, Google jumped and said, no, the Earth is not flat, it's roughly a sphere. So this is very biased, isn't it? I mean, not everyone agrees that the Earth is a sphere. There are some people, I don't know if many people, but who actually think that, and they contend that the Earth is actually flat. So I would say that Google is biased here. And I would also say that we are probably biased because we think this is okay for Google to react like this. But in fact, we are biased. In this case, we are biased for rationality, for scientific methods. Maybe we are biased to the axioms of geometry. Maybe if we pick different axioms, I don't know, the Earth, we wouldn't say it's approximately a sphere. And we also are biased to trust the scientific authority. I must admit that myself, I didn't really check that the Earth is a sphere. I mean, I may have this informal impression, but mostly I trust the people who told me that the Earth was spherical. So I'd say that we are actually biased by centuries of development of human thought, and which are ultimately subjective. So we maybe subconsciously we are taking sides, and we are basically we're not neutral, and we're basically underlying these are like a set of principles that we think are good, such as being rational, ethics, human rights, prosperity, dignity, and so on and so forth. Okay, so I think I made my point that bias and fairness is not that simple. And now let me go to the point that I want to talk about, which is the bias in recommendation. So recommendation is immersed in bias, and in a particular type of bias, which is the majority bias. So what is this? I think thanks to the previous talks, I don't need to explain this in much detail. So, I mean, what I'm showing here is the typical view of the recommendation task. You have a rating matrix with the blue cells are known data, observed data, and the white cells are missing data for preference by users for items. And this is not what the rating matrix looks like in reality. So the observations are not nicely uniformly spread across the matrix, but instead this is what we typically have. So a few popular items attract most of the observations, and the rest of items have only a few observations. And the distribution of observation typically follows a very skewed long tail with, like, a few bestseller taking all the interaction from users, and therefore all the observations for systems. The algorithms are also biased. Claudia has talked about this. What you are seeing here, these graphs, on the x-axis, you see the number of, each dot in the graphs is an item. The x-coordinate is the number of, the popularity, the number of positive interaction that the items got. And the y-axis is how many times this, or to how many users this item was recommended by different recommendation algorithms, collaborative filtering algorithms in particular. And you see there is a very strong bias. Like, the more popular an item is, the more times it is recommended by those different algorithms. And so there is bias in the data, in the algorithms, but also in evaluation, in particular in offline evaluation. Here you see the NDCG at 10 of, like, the green bars are good collaborative filtering algorithms. And the yellow bar is just a non-personalized recommendation based by, ranking the items by decreasing number of positive ratings, right? So you see that this recommendation doesn't do as good as the personalized algorithms, but still it achieves like a noticeable effectiveness, which can be surprising. In any way, there's a clear popularity bias, because it does much better than random recommendation, which is around here, hardly visible. And this is natural, because if the data is biased like this, and you split the data into test data for evaluation and training as input for the algorithms, then recommending items in this area, the popular area, will get you more relevance judgments in the test data, and so you will get a higher precision NDCG values, etc. So this, I would say, makes us feel a bit uneasy. At least it did for myself, like 10 years ago when I started working on these problems. And it makes us feel uneasy because we tend to think that bias involves some sort of distortion, right? So the evaluation would seem to be suffering distortion. On the other hand, I think we are mistrustful of majority, like following the crowd, because we associate it with herd behavior. And rightfully, because herd behavior, we know that it is often irrational, which means that by following crowds, we can get into trouble or get suboptimal outcomes. But I think we will all agree that following the crowd is useful in many contexts. Like, I go to a new city, I don't know where to eat, so maybe I just choose, if there's an empty restaurant and a full restaurant, I might choose the full one. Maybe not in these times where maybe we would go for for the restaurant on the bottom. But in normal circumstances, the majority signal is useful, and it is rational to imitate other people in many circumstances. So let me show you a couple of experiments where this is not my work. A couple of experiments where rational and irrational herd behavior emerge, because that's the question: when or what determines that following the crowd is rational or irrational? This is a well-known experiment where basically consisted of a few thousand people were given access to a set of 48 songs, and they could freely listen to them, and if they liked the song, they would download the songs. So this experiment was partitioned into 9 parallel worlds, and so in 8 of those worlds, people would see the download code of the items. So they had like information about what was the majority choice. And in the 9th world, people did not see that, okay? And so what happened is, so first of all, in these experiments, the authors observed that there is a high degree of randomness as to what is the most popular song, the most downloaded song. You can see here an example. So this is the graph, and each vertical represents a song, and each dot represents the number of downloads that in ranking that it got in different words. So you see that in some words, this song got plenty downloads, and this other word it got really very few. So this is kind of irrational, and the effect of this is that when there is social influence, because you can see the choices of others, as soon as a song becomes popular, there is like a boost in the popularity of this item. So if the item that becomes popular at the beginning is not like very good or whatever, so I mean, the sooner you become a bit popular, the more chances you have to get to the top of the popularity ranking. There is some stability because the most popular songs tend to be the most downloaded, and the least popular also seem to be. But in the middle, there is a lot of variation. They also observed that with social influence, the majority skew is much steeper. So here you see this is the distribution, the number of downloads in percentage. The red line represents a world where people could see the download count and were therefore influenced by other people. And the blue distribution is when the users were not exposed to this influence, and you see that it is flatter. Another interesting thing is that in the social influence board, the randomness of success was much higher. So this is a bit like represents like irrational herd effect, and you know, with social influence, irrationality would seem to be increased. This is another experiment where we see a bit of the opposite. We see some degree of rational herd behavior emerging. So in this experiment, it's just a simulation where people would choose items and interact with them, and everyone could see the count of interactions. So the user behavior was parameterized by 2 basic variables. One is that whether users chose popularity or quality to make their choices. So with probability beta, they would choose by popularity, proportionally by popularity, and with probability 1 minus beta, they would choose proportionality with 1 minus beta. And then there's another parameter that establishes how much effort the users are willing to invest in examining more, further below the ranking of popularity or quality. Interestingly, the optimal regime is not when users just take quality into account. So there is like a sweet spot here with where for some degree of social influence, so I mean, yellow means the color is the average quality, and yellow is top and black is the worst average quality. We see that the best results are achieved with some mild social influence and moderate effort. So the question is, in recommendation, recommending popular items, where are we when we recommend popular items? Are we in a rational recommender system or an irrational herd recommender system? And the question does not involve just the behavior of the algorithms, but also our perception, so our evaluation. Are we displaying some kind of rational or irrational herd behavior in a majority biased evaluation? So to address this question, we did a very simple experiment, which is, so we took a particular data set, which is Yahoo R3, that includes, on the one hand, the typical free biased ratings, so user interaction with music, free user interaction. But at the same time, this data set includes a number of randomly sampled ratings from users for items. So this allows to compute both biased and unbiased metrics. So if we take the random data as the test set and the biased data as the training set, we would be measuring an unbiased estimate of metrics, whereas we can also take just the biased data and do a random split and then measure biased metrics. Interestingly, this is the result that we got. So we would expect that the biased and unbiased metrics would be quite different. And the fact is that, so you can see here on one axis biased precision and unbiased precision in the other, and we see that the values are different, okay, but in terms of system comparison, we can see that there is a high degree of agreement. So these are like 16 recommender systems, and the Ken-delta correlation is quite high. So this, it would seem that in spite of the bias, the evaluation would display like rational behavior. So this is a bit surprising, and it makes sense to ask why this is. And also importantly, can we always expect this? Is this just one experiment that works like this, and maybe in the next experiment we would see something different? And we'd like to know when and when not this can happen. So, we delve deep a bit into this question. So first of all, the difference between biased and unbiased evaluation is how much data we get. And the thing is, if we have like a biased sample of user preferences, we're going to compute bias metrics. If we knew all the reference data of users for items, then we would have like true metric values. And if we have an unbiased sample, then we would have an unbiased estimate of the true metric value. So in reality, what we have is actually like two matrices. One matrix is the observation, the distribution of observations by the system, and the other is the distribution of relevance, user preference. And what the system actually gets is like an overlay of the observation distribution onto the preference distribution. So the question is, how does this determine the rational or irrational evaluation, so to speak? So one way to answer this is to think of how observations are produced. So they are produced by people, users discovering items and deciding to engage with them. When a user buys or interacts or clicks on an item, the recommender system gets an observation. And the overlay of these observations upon the relevance matrix gets the data that the recommender system can use and that we will use in evaluation. We can think of it as random variables: relevance, discovery, observation, items. And we can consider that there are dependencies between these variables, like a user is more likely to discover something, perhaps if it likes what they discover. And again, engagement will also depend on whether they like or not. But the thing is that we might have that or not. So we can have these dependencies on discovery and observation for relevance, or maybe not. It depends on how are the dynamics. So if we take like two extremes where observation is totally independent from relevance, or it depends only on relevance as the only property of the item that determines observation, then we get like interesting results. If observation depends only on relevance, and this would mean that the conditional probability of observation given relevance is a flat line with respect to the popularity, what we're going to get is, in general, that bias and unbiased evaluation will agree. Okay, we will have this type of trend. So this is the case. I mean, observation depends fully on relevance, for instance, or strongly on relevance when you use a search engine, a good recommender system, advice from friends, etc. The other extreme would be that observation does not depend on relevance at all. Like, for instance, if you are exposed to heavy advertisement that has nothing to do with your taste, or you are influenced by social conformity, fashion, virality, etc. This would be represented by a straight line between conditional observation to relevance and just the probability of observation. In this case, you can have different outcomes. If the observation distribution opposes the distribution of relevance, then interestingly, you get disagreement between biased and unbiased position. On the other hand, if there is no correlation, still you can get quite a strong agreement between biased and unbiased metrics. How can this happen? How can you have like an opposed distribution of observation with respect to relevance? This is possible in some, maybe not common cases, but so scenarios where there is like a negativity and virality. For instance, when you tweet about a flight, typically you don't say the flight was great, I arrived on time, the food was fantastic. You would probably, in that scenario, you would probably more likely be complaining if you tweet about it. Also, some other like innocent trends, like for instance, if you have that the items as they are produced, new items are better and better quality. You can have this trend, you know, in, I don't know, in like movie production or whatever. Then you can also have this inversion between relevance and the number of observations, because the older items would get, which are worse quality, would get an advantage in getting more observations. So we also did those were like simulations or theoretical analysis. Those results can be proven, but we also did an experiment with the data set that I mentioned before, and this is what we get. We observed that in terms of dependence from relevance, we see that the observations, they are neither independent, fully independent from relevance, nor fully dependent on relevance, but that we see some trend of dependence from both relevance and also, I mean, so from the items, regardless of relevance. So there is a mix of basically of both dependencies. And there is a positive trend in the relation between relevance and observation that we see in this graph. And this is the actual result. So biased and unbiased evaluation seems to agree to a good degree in this mixed case. So, yeah. So to conclude, I think all I explained can be summarized in this quotation from the grandmother of Bertrand Russell, like, don't follow a multitude to do evil. Majority bias recommendation is reliable, is rational, if what people find, what people choose is guided by relevance. It actually doesn't matter if it's positive or negative relevance. And when relevance is ignored, as long as the majority rank doesn't oppose relevance, we also can have reliable, I mean, the majority signal is useful and the evaluation is reliable. In general, we seem, I mean, in the experiment that I showed and others, we tend to see a mix of these two trends, but still the majority bias is useful and broadly harmless to evaluation. But in some cases, the trend can become inverse. There is more than I discussed to consider here. I just focused on relevance, but of course, there are other perspectives like novelty. Sometimes you just don't want the majority choice because you want to discover, you want to find new things, you want to take risks. And also, as Rishabh and Claudia were discussing, you may want to be fair and give equal opportunity to the items or to the providers of your items. This means that relevance being equal, all items should have a similar chance to be exposed to users, or even I would say that even if an item at some point doesn't seem to have gotten that much relevance, I think there is a virtuous cycle. If the items get exposed, if providers have an opportunity, they will improve in relevance. So I would say that relevance also builds, it's not a static thing, but it builds on exposure. And at the same time, users will learn to appreciate items that at the beginning may be not perceived as so relevant. And with this, I'm done and I'm happy to take questions.
Thank you very much, Pablo, for the fantastic talk. Let's just thank the speaker. So I would like to ask other speakers of the session turn on their camera and mics, and we'll just ask we'll have the Q&A as a panel. So I'll start with a question in the Q&A. It says, how to understand there is bias in an echo chamber scenario? That is, if user is surrounded by and have history of only one type of environment, the system's bias can it seems like unbiased. How to identify this type of biases? So Pablo, probably you want to start to answer this, but then also I would like to hear other speakers' thoughts as well.
So bias in an echo chamber, yeah. Yeah, so you mean there's the majority bias, but there's also the small minority, so to speak, bias. So yes, I mean, I think our analysis could be generalized to echo chambers, where an echo chamber is just like a cluster of popularity. And yeah, I would say that, I mean, we have addressed the problem with as few variables as possible, because just adding one more variable to the problem makes it much more difficult to address. But I think yeah, I mean, that would make total sense, and I think it would apply to that kind of scenario where the biases are in echo chambers, not just like the whole majority. I don't know if
Thank you so much.
I answered the question.
Any thoughts from Claudia or Rishabh on this?
Yeah, I can say a few words. I think like one of the interpretation I look at this is, I mean, I would love to investigate why this is happening. Are we, I mean, in a recommendation setting, are we recommending content and the user is again and again picking up that specific item, or is our recommendations bias itself? So again, like if you look at any of these platforms, so a platform has multiple like touch surfaces, right? So like the homepage is like purely recommendation, while search is purely like user need driven. So I think there's a variety of surfaces, and there you can see that, I mean, maybe some of these biases, this echo chamber aspects are more prominent in the organic consumption, not in the program consumption or vice versa. So organic is like what the user would do by themselves if there's no recommendation. And program is like, what is the program and what's the recommendation offering? So I think like understanding the differences between program and organic consumption would also go a long way in just understanding like, where is this echo chamber happening? Is it just purely in the user preference models, or is it also baked into the programming decisioning as well?
Yeah, thank you very much. So another question says, based on the picture of baseball field, do you think that we need to implement the rules of measurements, rules of relevance in a different way between different items to achieve equity, or should we implement on all items in the same way? I think that's for Pablo.
I think you're on mute, Pablo.
You are mute, Pablo.
Yeah. Thank you. No, I was trying to figure out exactly what was the picture of a baseball field.
Oh,
But yeah,
I was thinking if you want, you can answer this question offline, or do you?
No, it's okay. I mean,
okay.
But I mean, I guess, yeah. So I mean, at least that's what comes to mind. So should we be fair to items regardless of relevance, or just taking relevance into account? Like give a chance of exposure to items, assuming they are relevant or regardless of relevance. And I'd say there is no simple answer to that. Both make sense. Of course, if an item is relevant, you have one more reason to give it exposure. But even if you have not much certainty about the relevance of the item, I think it makes also sense to do some kind of like affirmative action, to see, really expose the item and see, to build relevance as well.
Thank you very much. I actually like to squeeze one question in myself, if that's okay. The kind of a theme between the three talks was the effects of, recommendation, diversity, exposure, and so on. And I was wondering, how do you guys think that it would affect the engagement of the users with the product or materials? For example, how people will consume the news if you're providing diversity in Spotify domain. How would the diversity of exposure would lead on to skipping effects, and in the recommender systems would be on the effects of accepting the recommendation and following on in like a movie lens or any sort of scenario as such. So if you guys have any thoughts on this.
So maybe I think Rishabh already had this in his talk a little bit, right? That there are different people who are able to different extent to accept what is unexpected, let's say that. And I think the same holds for news, right? Not every person is willing to, to be exposed to other points of view. But I do think that in order to at least to try to provide this level of fairness, you as a content provider, you should deal with this. But of course, as a content provider, you also have other constraints, right? You need to earn money. You cannot lose customers. So I don't think there's an easy solution to say, well, it needs to be fair, it needs to be diverse. Because in the end, the KPI of the content provider is never that, right? So there needs to be, to me at least, a certain extent of regulation. To some extent, you need to force them to adhere to certain rules. But I also understand that, the side of the content provider that simply is interested in earning as much money as they can. So it's definitely a very difficult problem.
Just to add a bit more to what Claudia was mentioning, like, I think I also view that. So one is there's this temporal view at diversity as well. I mean, one of the ways in which we can look at diversity is like in a hope to inculcate habits. So if I'm showing you 5 things, like 3 of them are new to you, if you see them over and over enough, you might just kind of get more familiar with that content, like subconsciously as well. So again, like this could be like if you're using like music versus podcast, like you might not listen to stream podcasts at all, and then you start getting familiar. Oh, actually, there's platform like this platform also had podcast. So I think like diversity plays multiple roles here. One is like just kind of inculcating these habits in users, but also, as I mentioned, like diversity also is important for, like, as a platform, you can use diversity for exposing some of these suppliers as well. So I think like, and some users are okay with it, some users are not. So I think like keeping in mind these things, there are ways in which you give the users who really care about diversity, you give them what they want and they're happy. And for the users who don't, then maybe as a platform, you can decide, I'm not gonna kind of worry them with like diverse content. The question is like, where do you draw the line? Do you still show diverse content to users who don't like diversity, or do you want to kind of inculcate these habits for the long term or not? I think that's one of the platform level questions as well.
Yeah. Pablo, do you have any thoughts on this, or should we move to the next question? We're actually getting a lot of interesting questions coming in. So
yeah, we can continue.
Okay, so we have a question from Sean. It says, being factual versus being fair, is this a reasonable problem? We don't want the systems to be inaccurate. However, at the same time, correct information could be considered as biased for certain communities.
So to that, I would say that I mean, one thing is factual is ultimately is a subjective concept, I think. You know, if you really want to define fact or truth, if you go to, philosophers, there's so many definitions and different views. So I would say that at some point you have to take sides to what you consider. I mean, what are the principles that you believe in somehow, and then from those principles, then you have your own definition of what is fact. Like, for instance, is the Earth a sphere? Is the Earth flat? If you want to be fair, you would say, okay, I'll have like half my results for this query will be the Earth is a sphere, half would be the Earth is flat. If I don't take sides, but why do I think about that? I really don't believe in the principles, magical thinking, whatever, that can lead you to believe that the Earth is flat. So I'm taken aside. I think you want to be fair, but you also maybe want to stick to some strong root principles. So, I mean, at the same time, I think you shouldn't like hide the fact that there are many people who think that the Earth is flat. So you should give also a chance to that view. Actually, if you check the Google's results, you will see also some links to the website of flat earthers, and you will also find links to, I would say, not like activist answers, but just like discussion. How to understand flat earthers, for instance. I think that's a good answer. Or how, I mean, like a rational discussion about this. And so you can at the same time give a chance to everyone in every type of thinking. Maybe there is some extreme cases of I would say opinion or thought that maybe you just want to fight definitely completely, I would say, right? But even for thoughts that you think are not good, like for instance, you think the humanity will not be happier, maybe we would be more miserable if we lived on the thought that the Earth is flat, I think. So this is why, okay, for the good of everyone, I'm going to take a side. So that's my complex answer for Sean's question.
Claudia, Bishop, do you guys have anything to add, or would you move on to the next one?
Okay, moving on.
Okay, so the next question is from Miriam. The question is targeted to Pablo. It says, we have observed in our latest research that in the context of social media recommendation, popularity leads to the spread of misinformation, despite the relevance. So how to balance the tolerance to bias in those contexts where bias can lead to online harm?
I'll take that one. Hi, Miriam. I'll try to be short because I've been logging the previous question. So I think this might be a case where there is some sort of negativity trend, like the things that become more popular are not the ones that are more relevant or whatever, or more true. But in spite of that, maybe because of the I don't know, the stimulus that we get from this false information, we tend to spread it, we tend to interact with it, we tend to click, read, etc. So I think this is a case where the distribution of observation is not aligned, does not correlate with the distribution of relevance or quality or truth or whatever you want to call it. And in those cases, I think that's what you get. You get like an irrational herd behavior on the part of the recommender system. And even if you evaluate, if you do an experiment with this data, you will have an irrational herd behavior in your metrics, in your experiment, because you are, I mean, in this case, the data is really distorted as to what is more relevant or more useful or more valuable.
So let's just take the last two questions of the session. And thanks so much for staying over. I know it's a lunch break, so we'll try to get over these two questions as well. But it's just a fantastic talk and a very interesting discussion. So the next question is again for Pablo. Says, can you see your findings being applied to other biases?
Yes, yes. Actually, I think so. Like, for instance, yeah, you can have, and I have experienced this. So like, I was representing the popularity bias as a rating matrix where the ratings are more concentrated in some part. But you could also have like clusters of rating concentration. That can be another type of bias. Like, for instance, different countries can have different, people can be exposed to different distributions of information spread or filter bubbles as well. So yes, I think the problem is quite similar. It's quite similar. Actually, for instance, there are algorithms like nearest neighbors, collaborative nearest neighbors, that builds on the existence of clusters in real user preferences. But if you have, in your overlay observations, you have clusters between users that don't match the clusters of preference, then your evaluation can be similarly distorted. So I think, yes, absolutely. This analysis would generalize to other misalignments of biases in the observation and biases in relevance. That can be not just on a single variable, which is the items, but on user and item variables or other features, demographics of users, or other sorts of features. Yes.
Absolutely. So the last question is that I like the idea of diversity, but would one go as far as showing the earth is flat? I ask in the context of Pablo's point early on about bias in favor of scientific thinking. So the question is, would one go as far as showing the earth is flat? So
yeah, well, I'll be very short. So I think I explain my position. I would say, I mean, yes, I think people should know that there are other people who think that the earth is flat. Maybe I would take a side if I was a search engine, and I don't know if I would do as Google, like not even wait that the user presses enter, but why not? I mean, you take a side, actually, why not? You really believe it's good for, but I mean, it's illustrative. I would encourage you to check search engines and see what are the results. And it's very interesting because there appears to be, they have thought about it, I think, because they do show pointers to flat earthers making that point, but they also, I mean, they also give you at least the elements for you to take your own answer. You know, Google takes a side, but at the same time, it still gives the chance for everyone to see, to check all the arguments and run to their own conclusions. So I would say yes. I mean, maybe if someone is saying we should kill humanity, maybe I would take this result, or no, I don't know. Maybe that would be a case for taking out this, not being that diverse. Or yes, I'm not sure, but I think that would be debatable.